This video is a review of several of the things that I've taught about electrons and atomic structure in the last few videos. So one of the things we talked about is how when the periodic table is arranged by valence electrons in groups, that different elements have the same sorts of properties. And because of that, we've given names to the different areas of the periodic table. Now I want you to memorize those, so I'd like you to pause the video and figure out where all these names fit. I've scrambled them in this list of 9 names up here. Where do they go on the periodic table? See how much you remember. Pause the video now, please. Okay, so you have taken the time to try these out, and here come the answers. Spoiler alert. First neighborhood, group 1, is called the alkali metals. Group 2 is the alkaline earth metals. I wonder if I can type this faster. I'm going to give that a shot. Number 3 is the transition metals. We've got over here the post-transition metals. And down here, these 2 rows are the inner transition metals. That's all the metals on the periodic table. This dividing line here separates the metals from the nonmetals, and that's called the metalloids. And we've got the reactive nonmetals. And then finally we've got group 17 and group 18. Group 18 is the noble gases, and group 17 is called the halogens. I hope you got them all right. If you didn't, that's okay. We'll keep practicing. Do better next time. More practice. Just looking at numbers 1 and 2 here. Again, I'd like you to read the question here, pause the video, try these out on your own paper, and then when you come back, I will give you the answers to see if you got those right. Okay, so you've paused, and question 1 about oxygen is how many valence electrons? Well, the easiest way to figure that out is to pop open a web browser and go to ptable.com. And they're asking me for money, that's new. Take a look at oxygen, and you can see pretty quickly that it is in group 16. And group 16 means it has 6 valence electrons. Bohr diagram. For that, I need the total number of electrons. Well, oxygen is number 8, so it has 8 total electrons. So here's a Bohr diagram. First shell, 1, 2, second shell, 3, 4, 5, 6, 7, 8. There's a Bohr diagram. Lewis dot structure is valence only, so I'm going to write the letter O because it's oxygen, and the valence electrons, again, it's just 6. You can see that on the Bohr diagram because the second shell is the valence shell. Helium is He. Find it on ptable.com. It's up in the corner here, group 18. Tempting to say, hey, it's in group 18, 8 valence electrons. Nope, helium is number 2. So it couldn't possibly have 8 valence electrons because it only has 2 electrons total. Okay, and both of those are valence electrons. So helium is an exception in the noble gases. Bohr diagram. You're only going to need 1 shell for this with 2 electrons in it. Since that's the only 1 shell, that is the valence shell, and you can see there are the 2 valence electrons. So here is the Lewis dot structure. Okay, hope that went well for you. Last bit of review here. Last week I made a video and we talked about the electron configurations. Okay, these are the newest, latest and greatest way for chemists to describe where all of the electrons are in an element, okay? And I taught you that each little part in here tells you something different. So this, as a reminder, is called a coefficient, and that tells what energy level we're looking at. So we're looking at energy level 1. The letter tells us which subshell we're looking at, because we learned that the Bohr diagrams really don't tell the whole truth. If you see 2 rings in a Bohr diagram, well, that's actually a 1s subshell, and then the second energy level has a 2s and a 2p subshell. It's actually 2 energy levels that are very close together, and the Bohr diagram doesn't show that. So the letter tells us the subshell, and then finally the superscript tells us the number of electrons in that energy level and that subshell. So here in number 1, we're saying in energy level 1, S subshell, there are 2 electrons. In this element, in energy level 2, also in an S subshell, there are 2 more electrons. So that tells me that I have 2 plus 2, or 4 total electrons. I just added up the subscripts, right? There's a subscript, there's a subscript. And then I just got to look for your number 4. Well, number 4 on the periodic table is beryllium, Be. So I figured that one out. Why don't you go ahead and pause the video and try this one yourself. 3, 2, 1, pause now. Okay, you've paused the video. Hopefully you realize that this is about the same as number 1. You're just going to add up the superscripts, because that's the number of electrons. So if I add them all up, I get the total of 9 electrons. And then when we look on the periodic table, we see that number 9 is fluorine. So this is F. And finally, number 3, by the way, is 1s1. That's 1 electron total. The element with 1 electron is hydrogen. And that's it for review.